The question says that two long and parallel straight wires A and B carrying currents of 8 ampere and 5 ampere in the same direction are separated by a distance of 4 cm. Estimate the force on a 10 cm section of the wire A. We know that parallel wires carrying currents exert magnetic forces on each other due to the interaction of their magnetic fields, and the direction of force is given like if the current in the wire is along the same direction, then the force will be attractive in nature, and if the current flows in opposite direction, then the wires will repel each other. Now magnitude of this magnetic force is given by mu naught I1 I2 by 2 pi d, where I1 and I2 are the current in each wire, and mu naught is the permeability of the free space, and its magnitude is 4 pi into 10 to the power minus 7 Tesla meter per ampere, and L is the length of the wire under consideration, and here d is the distance of separation distance between the two wires. Now we have been given the value of I1 and I2, that is the current in both the wires. We have also been told that they are in same direction. Current is flowing in same direction, and we have been given the distance of separation of the wires. Now we have to calculate force on the 10 centimeter section of wire, that is 0.1 meter. So after substituting the data that has been given in the above formula, we come to the result that the force of 2 into 10 to the power minus 5 Newton is applied by wire A on wire B or wire B on wire A, and the force is attractive in nature because the current is flowing in same direction. Thank you.